Alright, so we're going to be graphing 56 using transformations, not necessarily what the instructions they ask you in the book, but we're going to use transformations. So we have negative a right here, and then k. So a and k affect the y, so here's how it affects it, and nothing in this problem affects the x because h is 0 and b is 1. Okay, so let's go ahead and transform points. So x is 1, and then 0 plus 2 is 2. And then this is 3, and then negative 1 plus 2 is 1. So now we're going to graph it. Alright, so logarithmic functions have vertical asymptotes, which are determined by the h value. So right here, h is 0. So then I have this vertical asymptote right here, x equals 0. Then the points 1, 2, and 3, 1. Okay, now besides these 2 points and the vertical asymptote, I'm going to also ask you for domain and range and x-intercept, y-intercept. So I'll put it here. We know that the range for any logarithmic function is all reals. The domain depends on the h value. That tells you the boundary. So right here h is 0, so it's going to go from 0 to infinity. Or you could write it in set notation like this. Okay, and so let's see, x-intercept and y-intercept. X-intercept, we could say none there because it's never going to cross through, sorry, backwards. Y-intercept is none. Or you could just put the empty set. Let me erase this. For the x-intercept, we make the y equal 0 and solve for x. So I'll do the work right here. So 0 equals 2 minus log base 3 of x. I'm going to subtract 2 from both sides. So negative 2 equals negative log base 3 of x. I'm going to divide by negative 1, so that makes that a positive and that a positive. So I have log base 3 of x equals 2, so that means that 3 squared equals x. So that means that x equals 9. Okay, so on 9, 0, so let me put the x-intercept right here, would be 9, 0. Okay, so 4, 5, 6, 7, 8, 9, so right here. So it's going to go something like this. Like that. Okay, so here's the domain, the range, the x-intercept, the y-intercept, and the graph right here. Alright, so here we have a logarithmic function with base 1/2. Reference points are 1, 0 and 1/2, 1. In orange you see that h is positive 2, so I put x plus 2. The a is negative 1, so I put negative y. Okay, so that's how the points are going to change. So the first point, 1 plus 2 is 3. Opposite of 0 is 0. 1/2 plus 2 is 2.5. And then the opposite of 1 is negative 1. So now we're going to graph it. Alright, so h is positive 2, so that means that your vertical asymptote is going to be at x equals 2, right here. The two transformed points, 3, 0, and 2 and 1/2, negative 1. So that would be about here. Okay, so we could connect the points. Go something like this. We need to get the domain, the range, list the intercepts. So domain it's from 2 to infinity. Or you could say all x such that x is greater than 2. One or the other. Range is all reals. Vertical asymptote, x equals 2. And x-intercept, well, that one's easy because it's already here on the list. So 3, 0. Y-intercept, again, this one has none. Alright, so 127, they give you an exponential function right here that gives you the population in North Carolina from the year 2000 to the year 2012. So in the year 2000, this is the initial population in millions, so 8.06 million. T is the year since 2000, so when in the year 2000, T would be 0. Okay, and we want to find K for the first part when in the year 2001, the population was 8.21 million. And so with that information, we're going to find K. So we're going to replace the P with 8.21. And this is 8.06. And then in the year 2001, T is 1. So then this, we're going to divide by 8.06. So this gives me e to the k equals 8.21 over 8.06. So I'm going to do the natural log. So k equals natural log of 8.21 over 0.06. So whatever you get here in the calculator for this, that's your answer. Alright, so taking a calculator, you find the natural log of 8.21 divided by 8.06, and you get this. I'm rounding it to 5 decimal places. I think the book is going to ask for 4, and on the test I'll let you know if you get a problem like this. So so that's part A, where they want you to find A. So for part B, they say, using this model, what do you predict the population will be in the year 2020? So I already set it up right here. We're solving for P, and I put the 0.01844 for K. Now, it's still on my calculator screen, the whole number for K, without rounding. So I'm just going to multiply it by 20. And so that's going to give me 8.06e to the 0.36879. Again, I'm rounding it off here to 5 decimal places, but I'm actually keeping the whole number on the calculator screen. So now I'm going to take the e to that power, so e to the answer power times 8.06. So that's going to be the population. It will be approximately 11.65 million.